Hello, dear all. Today, let us learn some of the numericals on the non-state equation. In my previous video, we have solved eight videos, eight problems. So let us continue with some other type of numericals, which is based on the non-state equation. This is the ninth problem. The problem is like this: calculate the EMF of the following cell. The cell is given here: zinc slash zinc 2 plus of concentration 0.01 molar double slash Cu2 plus of 1.75 molar slash Cu. This is the given cell. For this, we have to calculate the EMF, and they have given the standard reduction potentials of zinc and copper. They are 0. Minus 0.76 and 0.34 volts respectively. How to calculate this? Let us go to the first calculation, that is E naught cell. So this is a well-known formula. E naught cell equals E naught of cathode and minus E naught of anode. So here cathode is a copper and zinc is an anode. Zinc is more anode to the copper. That is, we know that. So E naught cell equals E naught of copper minus E naught of zinc. So copper and zinc values already they have given in the problem. Copper is 0.34 and zinc is minus 0.76. So therefore, the answer is E naught cell equals 1.1 volts. After this, let us go to the calculation of EMF using the well-known formula. E equals E naught plus 0.0591 divided by N log of concentration of copper 2 plus ions divided by concentration of Zn2 plus ion. That is, copper is 0.34, copper is 1.75 and concentration of zinc is 0.01 as given in the cell representation in the above problem. So this E naught we have calculated in the previous step. It is 1.1 and number of electrons both are divalent. So 2 electrons are involved. Therefore, N is 2 and this is the given value 1.75 divided by 0.01. On the simplification of this, we will get E equals 1.1 plus 0.0296 into this ratio becomes 2.24. So if multiplying 2.24 by 1.01296 and adding 1.1, we will get the answer of 1.166 volts. This is what the EMF of the cell zinc and copper cell. And let's go to some other problem. The problem number 10. What is the concentration of nickel 2 plus ion in the cell if the EMF is 0.601 volts? The cell is Ni slash Ni2 plus of A molar concentration double slash Cu2 plus of 0.75 molar concentration slash Cu. Given that the standard reduction potential of the copper and nickel is 0.34 and minus 0.25 respectively. This is one of the different kind of problem. Here we have to calculate the A. The value of A we have to find out. Concentration of the nickel 2 plus. So how to calculate this? Using the same formula. E equals E naught plus 0.059 divided by N log concentration of Cu2 plus divided by concentration of nickel 2 plus. So E value they have given in the formula, that is in the problem. It is EMF is 0.601, that I am writing here, 0.601 equals E naught. We have to add these two, that is 0.34 copper plus minus 0.25. So after if you use the previously used E naught cell is equal to E of cathode minus E of anode, we will get plus 0.25. Then N is here also the 2 because copper and nickel both are divalent metals. Log concentration of copper they have given here, that is 0.75, but they did not mention the nickel concentration, nickel 2 plus ion concentration. They have given it as A. This A we have to find out. So upon the simplification of the above step, we will get 0.601 equals 0.59 plus On dividing 0.0591 divided by 2, we will get 0.0295 log of this. I retain the same step 0.75 concentration divided by A. Further, upon simplification of above step, we will get 0.011 equals 0.0295 log concentration of 0.75 divided by concentration of A. Further simplification, let us take this logarithm ratio left side, log of concentration of 0.75 divided by A concentration equals this 0.375. This is on the simplification of this side. Next, for the concentration of 0.75 divided by A equals antilog of 0.375, and therefore it comes like this: 0.75 divided by A equals 2.3713, and hence A equals concentration of A, that is nickel concentration, is equal to 0.316 molar. 0.316 molar is the concentration of nickel 2 plus. Here in the place of A, we have to write. This is how we have to find out. In the next videos, let us learn how to solve the numericals or the problems on the concentration cells. Thank you all.